Hi, welcome to Trig review. So we've been adding vectors different ways, and you've done this a little bit. You've done the Pythagorean theorem, and you use the protractor and a ruler to do the graphical method. But in order to do the mathematical method the best and to be able to use the component method, you need to understand a little bit or review a little bit of what you did in your trigonometry or your geometry class. So first of all, we need to preface all of this by saying this is just for right triangles. You can't use this for any triangle that you want to. There are other rules and other equations for doing that, but this is just for right triangles. So we're either going to be given right triangles, we'll be given like two vectors that are at right triangles or at right angles to one another, and then you're going to use that to find the resultant, or you're going to have to take individual vectors and break them down into an x and a y component using these methods. So we need to understand sine and cosine and tangent a little bit better. Sine and cosine and tangent are just like fancy words that are really the ratios of the sides of these right triangles. So if you have a particular triangle that's a right triangle, there are two other angles that are not the right angle. And we usually call one of them theta. I don't know why. I call the other one alpha. You can call it whatever you want. But these are the rules. So SOHCAHTOA is what we normally use to remember the order in which everything goes. So the sine is the opposite side from that angle divided by the hypotenuse, which is the side opposite the right angle. And then cosine is equal to the adjacent side, which is the side that makes up the angle that isn't the hypotenuse. And that's divided by the hypotenuse. And then tangent is the opposite side divided by the adjacent side. And these are all lengths. So sometimes it'll be in meters or centimeters, but because this is physics and these are vector quantities, it can also, because the size of the arrow has to do with the magnitude of whatever the vector is, this could also be newtons or meters per second squared or any other quantity that happens to be a vector quantity. So we just need to review though what sine and cosine and tangent are. In math world, we almost always have a pretty triangle and they always ask you about one particular angle, and then you can just run through this. So I have a generic right triangle that I've made here. Here is theta, this is this angle right here. And so the sine of that angle by definition is the opposite side, which is, if this is just a generic version, it's just any old letter. So it's A, the opposite side, divided by the hypotenuse. The hypotenuse is the side opposite the right angle. The cosine of that very same angle is equal to the adjacent side. The adjacent side is the one that makes up the angle with the hypotenuse. So that's going to be, for my generic triangle, B divided by C. And then the tangent, by definition, is the opposite side, that's still A, divided by the adjacent side, that's B. So that's for this angle. Now everything is going to change when you start talking about the other angle. So if we know this angle for some reason, and we want to find the sine, cosine, or tangent, this opposite and adjacent sides are going to change because it's a different angle, but the hypotenuse will stay the same. So the sine of this angle alpha, that I'm calling it, is the opposite side, B, divided by the hypotenuse, C. And the cosine for this angle alpha is going to be the adjacent side, which is A, divided by the hypotenuse, C. And then the tangent is the opposite over the adjacent. So it depends on which angle you're talking about as to what you're going to do. So to put this into practice, I've made up a real simple example. Let's say we know, here's our right triangle, this is a 40-degree angle, and we know that the hypotenuse is 15 meters, and we want to find the size of length x and the size of length y, the other two legs of the triangle. So the first thing we need to do, if we're using a fancy calculator, is we need to make sure that it's set in degrees. To do that, you go to mode, and then you make sure it's in degrees and not radians. So in order to find x and y, I'm going to say the sine of this angle that I know, 40 degrees, is equal to the opposite side, which in this case is y, divided by the hypotenuse, which is 15 meters. And then to get y, I just simply multiply 15 meters times the sine of 40 degrees. I put that in my calculator. And I get, let's see, two significant digits. that side is equal to 9.6, and that's gonna be meters. Then to do cosine, the cosine of that 40-degree angle, here's my 40-degree angle, cosine is equal to the adjacent side, which is x, I don't know what that is, divided by the hypotenuse, which is still 15 meters. So that means that x is going to be 15 meters times the cosine of 40 degrees. So I take 15 times the cosine of 40 degrees, and I get 11.5, or 12 meters. And that's really all there is to it. There's a practice worksheet that you can do, and if you have any difficulty, make sure you contact me. Thank you.